Good morning. Continuing with our Myhill Nerode theorem for minimization of finite automata. Now we are going to minimize a finite state automata. Here we have a finite automaton which is having 6 different states: Q0, Q1, Q2, Q3, Q4, and Q5. And among these, Q2, Q3, and Q4 are final states. Q0, Q1, and Q5 are non-final states. Okay. Now, see. Now, as per our earlier discussions, now we have how many states? Q0, Q1, Q2, Q3, Q4, and Q5. And the equivalence classes are J0, J1, J2, J3, J4, and J5. That means where each state is an equivalence. Each state of this is represented by an equivalence class. And here, see, listen here. This Q0 represents all. It includes all the languages or all the strings which you are starting from Q0. You have to reach Q0. For example, that means starting from Q0, epsilon, without reading an input symbol, you reaches Q0. Now, on the first 0, you will go to Q1, and for the second 0, coming back to Q0. That means 0, 0 is the next input string. That if this is, that means if you process this 0, 0, after reading 0, 0, it will come back to Q0. Now, what will happen after 0, 0? Next 0, you will go to Q1, and next 0, you come back to Q0. That means 0, 0, 0, 0, 0, 0, next 6 zeros, 8 zeros, etc. That means if it is if the number of zeros are even, then this will come, the control will come back to Q0. Okay, that means that is why we have 0, 0 star. That means the star means it is clean closure. That means if this is occurring 0 times, that is sigma. If this is occurring 1 time, we get 6, 0, 0. If it is happening if this star, this is 2, then 0, 0, 0, 0, and 3, 0, 0, 0, 0, 0, 0, and 4 times, 5 times, 6 times, etc. That means this is clean closure, and these set of strings are represented by 0, 0 star. Now, Q1 is odd number of zeros. That means 0, 0 star followed by another 0. That means here the minimal length string accepted by this is 0, simple 0, you reach here, you will reach here 3 zeros, 5 zeros, 7 zeros, etc. And that is represented by 0, 0 star 0. Okay. Now, what will happen for the next one? That means here this is Q2. That means here, if you are considering this Q2, then starting from Q0, the set of states or the strings which causes the control to reach Q0 plus 1. That means after that Q0 to Q0, you have to start from Q0, you have to reach Q0 and then to Q2. Q0 to Q0 and then to Q2. What is Q0 to Q0? That is represented by this string and followed by 1. Followed by 1. That means the string which causes the control to go from Q0 to Q0 and then to Q2. That means Q0 to Q0 we have 0, 0 star, and after that 1. That is why 0, 0 star 1. Now, what is the set of strings which causes the control to reach Q3 from Q0? from Q0 you have to reach Q1 and then to Q3. That means the string which causes the finite control to reach Q1 from Q0. That means Q0 to Q1 and then to Q3. What is the set of strings which causes the finite control to reach Q1 from Q0? That is 0 0 star 0. That means this is 0 0 star 0, and after that from Q1 to Q3 1. That is why you have 0 0 star 0 1. Okay. Now J4 is the set of strings causes the finite control to reach Q4 from Q0. Q4 from Q0. From Q0 to Q4, you have how many different routes are there? That means one is through Q0 to Q2 to Q4. And another way is there Q0 to Q1, Q1 to Q3, and then Q3 to Q4. That means Q0 to Q1, then to Q3, and after that to Q4. Okay, see, for this is the first route, the string Q0 to Q4. What is that? Q0 to Q2, what is that? Q0 to Q2 is 0 0 star 1. That is 0 0 star 1, and after that Q2 to Q4. What is Q2 to Q4? Q2 to Q4 is 0 0, and after that here also you have a 0. This is the original one, and after that you can have many number of transition from Q4 to Q4. That means after reaching Q4 can have this 0 successor. That means the 0 successor of Q4 is Q4 itself. That's why can have 0 star. Okay, that means 0 0 star, after that 1, again 0, and after that you have a self loop here, that is why 0 star, or this or. That means you can take either this route or this route you can take. Okay. Now what is that route? Q0 to Q1. Q0 to Q1 is 0 0 star 0 0 star 0. After that causes the control to reach Q3 from Q1. That is 1, and after that another 0 followed by 0 star. See, we have 0 0 star here, 0 0 star here. Now 0 0 star, take it as a common expression. That means 0 0 star, the meaning of this is even number of zeros, and meaning of this is odd number of zeros. That means odd number of zeros or even number of zeros means zeros. That means a number of zeros followed by 1 0 0 star. Okay, that is 0 star 1 0 0 star. And once you reach here, you can have a transition for 1, and then you have 0 or 1 star. Okay, and that is written here. When we are discussing, we would have already discussed regular expressions. If you are not aware of regular expressions, then you have to go through these regular expressions in detail, and then you can easily follow this. Okay, now we are going to minimize this. So before going into the details of this, now we have to find equivalent states. If two states P and Q are equivalent, we write it as this: P is equivalent to Q. P is equivalent to Q if for any x element of sigma star, for any x element of sigma star, delta of P of x and delta of Q of x are both in final state or both not in final state. Okay, that means suppose that I am going to have check whether Q0 and Q1 are equivalent. I am going to check whether Q0 and Q1 are equivalent. For that, what I have to do is you are going to apply, say, I am going to apply say 0, 1. That means I am going to find delta of Q0 on 0, 1. What will happen? Q0, after accepting 0, it reaches Q1, and after accepting the next one, it reaches Q3. That means this is Q3. What about delta of Q1 on 0, 1? Q1 on 0, 1, Q1 on 0 it is Q0 and Q0 on 1 it is Q2. This is Q2. Both are final states. That means our condition is for any input string you have to find out the transition and either both of them should be accepted or both of them should be rejected. That means one final state and one non-final state is not allowed. That means here delta of Q0 on 01 is Q3 and delta of Q1 on 01. I am going to find whether Q0 is equivalent to Q1. In that case, this is as per I am going to apply 01 on Q0 and Q1. Then in both cases you get Q3 and Q2. Those are final states. Now suppose that we are simply 10. Another string 10. What will happen to Q0? Q0 on 10 is Q0 on 1 is Q2, and for the next 0 it reaches Q4. And what about Q1? Q1 on 1 it reaches Q3, and for the next 0 it reaches Q4. That means this is Q4 and this also is Q4. That means you have to try different inputs. Here you have to apply different inputs, and you try to make, that means suppose that one of this reaches final state and one is another one to a non-final state. That means these are not equivalent. If now our test is over, then you have to apply simply 1, 1, 1. And here also I am going to apply 1, 1, 1. What will happen? Q0 on 1, 1, 1 is Q0 on 1, next Q2 on 1, and that is Q5. That means this is Q5. And what about Q1 on 1, 1, 1? Q1 on 1 is Q3, and Q3 on 1 is Q5, again Q5. That means both are Q5, both are non-final states. That means this Q0 and Q1 are equivalent. Q0 and Q1 are equivalent. Now Q0 and Q1. Q0 is equivalent to Q1. And now I am going to check whether Q0 and Q2 are equivalent. Q0 and Q2 are equivalent. I am going to check whether delta of Q0 on an input string equal to delta of Q0 and Q2 on some string equal to. That is, if you are applying 1 here, Q0 on 1 and Q2 on 1. Q0 on 1 is Q2 and Q1 on 1 is Q5. This is Q2 is a final state and Q5 is a non-final state. That means these two are not equivalent. Okay. Now, anyway, you should, a final state and a non-final states are always not equivalent. Here, Q0 and Q2 not equivalent, Q0 and Q3 not equivalent, Q0 and Q4 not equivalent. you have to check whether Q0 and Q1, then Q1 and Q5, and Q0 and Q5. Whether these are equivalent, you have to test. And now Q2, Q3 and Q4 forms another set, and you have to check whether these are equivalent. That means you have two states, two sets. Now a set of non-final states and set of final states. Okay, set of non-final states and set of final states. Now I am going to check whether Q0 and Q5 are equivalent. Q0 and Q5 both are non-final states. If you are applying Q0 on 1, it reaches Q2, and Q5 on 1 as Q5 itself. That means one receiving one, Q0 goes to a final state and Q5 goes to a non-final state. That means those two are not equivalent. There is no need to test another string. Then I am going to test whether Q1 and Q5 are equivalent. If you are applying Q1 on 1, it reaches Q3, and Q5 on 1, it reaches Q5. That means Q3 and Q5 are, this is final state and this is non-final state. That means Q1 and Q5 are not equivalent. So these two are not equivalent. Q0 is not equivalent to Q5. Q1 also is not equivalent to Q5. That means Q5 is another state. That means that is not equivalent to any other state. Now we are going to check whether this Q2, Q3 and Q4 are equivalent. Now I am going to test whether this Q2 and Q3 are equivalent. Q2 and Q3. Q2 on 0. Q2 on 0, it reaches a non-final state. Q3 on 0. Q2 on 0. Q2 on 0, it reaches a final state. Q3 on 0, it reaches a final state. Okay. What about 1? Q2 on 1. Q2 on 1, it reaches a non-final state. Q3 on 1. Q3 on 1, it reaches another non-final state. That means now you have to test with another say 0, 1. Q2 on 0, 1, what will happen? Q2 on 0, 1 is Q2 on 0, Q4, and for the next one, it reaches Q5. What about Q3 on 0, 1? Q3 on 0, 1, it again reaches Q5. That means that test is also successful because it reaches a non-final state. Now 0, 1, 0. And you have to try different strings, and in this case the test is successful. That means Q2 is equivalent to Q3. Now you have to test whether Q3 and Q4 are equivalent, or Q2 and Q3 are equivalent. If Q2 is equivalent to Q3 and Q3 is equivalent to Q4, then these three are equivalent. Okay. Now you are going to test whether Q3 and Q4 are equivalent. Q3, Q4. Q3, comma Q4. That means testing. We are going to test string. Say 1, 1. Q3 on 1, 1. What will happen? Q3 on 1, 1. It reaches Q5. What about Q4 on 1, 1? Q4 on 1, 1. Again it is Q5. That is successful. Try out another 0, 0. Q4 on 0, 0. What is that? Q4 on 0, 0. It is staying in the same state. And Q3 on 0, 0. It is staying in the same state. That means here Q3 and Q4 also equivalent. Q3 and Q4, which is equivalent to Q4. That means Q2, Q3 and Q4 are equivalent. Q0 and Q1 are equivalent. Q5 is not equivalent to any other one. Now I am going to rewrite this. That means I am going to have Q0 equivalent to Q1. That means I am going to replace these two. That means Q0 and Q1 with Q0 equivalent to Q1. Then I am going to have a final state like Q3 equivalent to Q4, Q2 equivalent to Q3 equivalent to Q4, which is another state, and finally you have Q5. Q5. Okay. Now what will happen? Q0 1 0. It is going to Q0 1 0. It is Q1 and Q1 belongs to that state itself. That means 0. What about Q1 1 0? Q1 1 0 is Q0. That means both are same. Now what about Q0 1 1? Q0 1 1 is going to Q2. Q2 belongs to this Q2. What about Q1 on 1, that is going to Q3 and Q3 also belongs to this. And what about Q2, Q3 and Q4? Suppose that it is accepting Q2 accepting 1, what will happen? It is going to Q5. That is why you have 1 here. And Q2 accepting 0. Q2 accepting 0, it is going to Q4. Q4 accepting 0, it is going to Q4. And Q3 accepting 0, it is going to Q4. That means here we have 0. And Q5, here upon receiving 0 and 1, is staying in the same state, 0, 1. That means this is the start state. See, this is the way we are going to minimize the expression. Minimize the finite state automaton. This is one way of doing that. And in this case, you have to find out equivalent states. If two states are equivalent, a final state and a non-final state never be equivalent. Can never be equivalent. And if you have two states P and Q, first of all, what you have to do is you have to split this into final states and non-final states. I will show you that. Final here, what are the final states? Q0, Q1 and Q5. These forms one group, and another group is Q2, Q3 and Q4. Q2, Q3 and Q4. Now check whether these are equivalent. Q0, Q1 and Q5. For that, Q0 and Q5, take the pair Q0 and Q5, or Q0 and Q1. When you are testing the pair, then both are equivalent. Then you are testing whether Q0 and Q5. Then what is this? Q0 10, Q5 10. You have to check. Q0 10 is going to Q2, and Q5 10 is coming back to itself. That means Q0 10 is going to a final state, and Q5 10 is going to a non-final state. That means this Q5 is you have to split this. Now this becomes Q0, Q1 forms one set, one pair, and Q5 another pair, and Q2, Q3, Q4 another pair. Q2, Q3, Q4 another pair. Now, if you test Q0 and Q1, that belongs to the same. These are equivalent, these are equivalent, and these are equivalent. Okay, this is the way. You have to test this yourself. You have to do that, and with this, this is the way, one of the way to minimize a finite automaton. And there is another method which is using a table-driven method for finding the minimum state automata. That I will show you, and that's for now. And we are going to discuss the tabular method. Okay. Now, this is a problem, and this is the finite automaton which we are going to minimize. For that, I have created a table like this. Here, how many states are there? Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7. So 8 states are there. Then you have to draw a column like this. Here you should have 7 columns at 7 by 7, and you have to do this like this. And here for every pair of states, a single entry is there. For example, Q0, Q1 is this, Q0 to Q2, Q0, Q2, Q0, Q3, etc. And Q1, Q2, Q1, Q3. That means for a pair of states, if you are having an 8 by 8 table, what will happen? Multiple different entries are there. Q0, Q1 is there, Q1, Q0 is there. For avoiding that, the corner entries are also deleted. Now you have to construct a table like this. Here you have how many states? 8 states. So here you have 7 rows and 7 columns, and you have to develop that like this. And from here you should start Q0, Q1 etc. not up to Q7, up to Q6, and here start from not from Q0, you have to start from Q1, Q2 etc. up to Q7. That means for a pair of states, only single entry is there. Okay. Now here for the original automaton, see what are the final states. Here we have only a single final state Q2, and if you have a pair of final states and non-final states, if you have a pair of non-final states and final state, that means Q2 is not there. Q2 is not there. You have not an entry like Q2, not an entry there. And for a non-final state and a final state, or for all the entries, if one of that is a final state and the other state is a non-final state, you have to put a cross mark here. Now Q2 is one final state and all other states are non-final, then all the entries corresponding to this Q2, those has to be marked. That means this Q2, okay, that means Q0 and Q2 are distinguishable. Why? Q0 is a non-final state and Q2 is a final state. Q1 and Q2, those are distinguishable. That means these pairs are distinguishable. That means those are not equivalent. Those are not equivalent. That is the meaning. So Q0 and Q2 are not equivalent. That means they are, if P not equivalent to Q means P and Q are distinguishable. That means you can easily distinguish both of them. If no, they are not distinguishable, that means they are equivalent. Okay. Likewise, Q0 and Q2, non-final state and a final state, non-final and final, non-final, final, non-final, final, etc. Now I have marked all the non-final and final states. Okay. Now I'm going to check whether Q1 and Q0 are distinguishable. Q1 and Q0 are distinguishable. For that, I am going to check whether Q1 equivalent to Q2 by looking at this table. Now, say delta of Q1 on 0, you have to find out delta of Q2 on 0. What is delta of Q1 on 0? Delta of Q1 on 0 is Q6. Delta of Q1 on 0 is Q6. And this is Q6. And delta of Q2 on 0. Delta of Q2 on 0 is I am going to check whether Q0 and Q1 are distinguishable. Q0 and Q1 are distinguishable. Q0 and Q1. I am going to check whether Q0 and Q1 are equivalent. For that, I am going to apply 0 to, that means on the input 0, what will happen to Q0, and on the input 0 to Q1, what will happen. What is Q0 on 0? Q0 on 0 is Q1. And what is Q1 on 0? Q1 on 0 it is Q6. Q6. Now you got Q1 and Q6. Then you have to go to the table and check whether Q1 and Q6 are distinguishable. Here Q1 and Q6. This is the location which is having that information. As that is not marked, we do not know whether those are distinguishable. So at this point, we are not able to say whether those are distinguishable, whether Q1 and Q6 are distinguishable. So at this point in time, by checking with 0, we are not able to arrive at a conclusion. Okay. Now we are going to input 1 instead of 0. I am going to put 1 here, 1 also here. What will happen? Q0 on 1. Q0 on 1 is Q5. Okay. Q0 on 1, it is going to Q5, and Q1 on 1, what will happen? Q1 on 1, that is Q2. This is Q2. Now check the entry Q2, Q5. Now what is Q2, Q5? This is the entry Q2, Q5, and Q2 and Q5 are distinguishable. As Q2 and Q5 are distinguishable, then these two are distinguishable. These are not equivalent. These are not equivalent because when you are applying Q0 on 1, you get Q5, and when you are applying Q1 on 1, you get Q2. As Q2 and Q5 are distinguishable, definitely Q0 and Q1 are distinguishable. That is why here you have put the Q1. Now go to this location. That means an easy method is here you have to fill up all the entries which are near to Q2. One of them should be near to Q2. That means here Q1 is near to 1. That means it's a one unit away. That means only a single edge is in between Q2 and Q1. That means you have to fill up all the Q1 entries related to Q1. Now we have to fill this, and then you have to fill this, which are related to Q1. Now what will happen to, now we are going to check whether Q1 and Q3 are equivalent. Q1 and Q3. For that, what I have to do is, what is Q1 on 0? Q1 on 0 is Q6, and Q1 on 0 is Q6, and Q3 on 0, what is that? Q3 on 0 is Q2. Q3 on 0 is Q2. That means Q6, Q2. The entry Q2, Q6 is distinguishable, so this is distinguishable. This is distinguishable. Now you are going to check whether Q0 and Q4 are distinguishable. For that, not Q0, Q1 and Q4. What will happen? Q1 and Q4 is this one. Q1 on 1, it is Q2, and Q4 on 1 is Q5, and Q2, Q5. Check Q2, Q5. As Q2, Q5 is distinguishable, this also is distinguishable. Now you have to check Q1, Q5. This entry Q1, Q5. Q1, Q5. Apply 0. Applying 0, what will happen? Q1 on 0 is Q6, and what is Q5 on 0? Q5 on 0 is Q2. That means Q2 and Q6. The entry Q2, Q6 is distinguishable, so this also is distinguishable. Now Q1 and Q6. Q1 and Q6, what will happen? I have to apply 0. Q1 on 0, it is Q6, and Q6 on 0 is Q6. We don't have any entries Q6, Q6, so you cannot arrive at a conclusion. And now we have to apply 1. What will happen? Q1 on 1 is Q2, and Q6 on 1 is what? Q6 on 1 is Q4. What about Q2, Q4? Q2, Q4 is distinguishable, so this is also distinguishable. Okay. Now what about Q1, Q7? Q1 and Q7. Say you are applying, we are going to check whether Q1 and Q7 are distinguishable. For that, you are applying 0. Q1 on 0 is Q6, Q7 0 is Q6. That means Q6, Q6. We are not able to distinguish those two. Now you are applying 1. Then Q1 on 1 is Q2, and Q7 on 1 is also Q2. That means we are not in a position to distinguish between Q1 and Q7. That means here we are keeping this a blank. Now we are going to fill all the entries, that means near to Q2 we have Q1. Now we are moving on to Q3. That means these entries you have to fill it up. These entries. What about Q3 and Q4? That means this entry is Q3, Q4, Q3, and this is Q4. Q3 and Q4. What is Q3 on 0? Q3 on 0 is Q2 and Q4 on 0. Q4 on 0 is 7. What about Q2, Q7? Q2, Q7. What is Q2, Q7? Q2, Q7 is distinguishable. So this is distinguishable. What about Q3 and Q5? Q3 and Q5. Q3 and Q5. If you are applying Q3 and Q5, if you are applying 0, Q3 on 0 it is Q2, Q5 on 0 it is Q2. That means they are not distinguishable. What about the other input 1? Q3 on 1 it is Q6 and Q5 on 1 is again Q6. That means we are not in a position to mark mark an entry here. So we are moving on to the next one. That is Q3 and Q6. Q3 and Q6. Now Q3 and Q6. What about Q3 on 0? Q3 on 0 is Q2 and Q6 on 0. What is Q6 on 0? It is Q6 and Q2, Q6 is distinguishable. Q2, Q6 entry is distinguishable, so this also is distinguishable. What about Q3, Q7? Q3 and Q7. What is Q3, Q7? Q3 on 0 it is Q2 and Q7 on 0. Q7 on 0 is Q6. Q2, Q6 is distinguishable. Q2, Q6 is distinguishable. So this also is distinguishable. That means entries near to or nodes which are near to the final stage is Q1, Q3. Now you have to fill Q5. Q5 you have to fill. Q5 and this entries also you have to fill it up. What about Q5 and Q0? What about Q5 and Q0? Q0 and Q5. Entries corresponding to Q4 and Q5. What is Q0 and Q5? Q0 on 0 it is Q1 and Q5 on 0 is Q2. Q1, Q2 is distinguishable. Q1, Q2. Q2, Q1. Q1, Q2 is distinguishable. Q1, Q2 is distinguishable. So this is distinguishable. Q0, Q5. Then the next entry corresponding to this is we are not in a position to fill this right now. What about Q5 and Q4? Q4 and Q5. Q4 and Q5. What is Q4 and Q5? Q4 and Q5. Q4 on 1 is Q5 and Q5 on 1 is Q6. Q5, Q6. What about Q5, Q6? That entry is not filled. So we are going to 0. What is Q4 on 0? Q4 on 0 it is Q7 and Q5 on 0 is Q2 and Q2, Q7. Q2, Q7 is already distinguishable. So this also is distinguishable. Q4, Q5. What about Q4, Q6? Q4, Q6. Q4 on 0. What is Q4 on 0 is Q7 and Q6 on 0 is Q6. What about Q6, Q7? That is not filled. Now you are going for 1. You are going to have a test with 1. What is Q4 on 1? Q4 on 1 is Q5 and Q6 on 1. Q6 on 1, what will happen? Q6 on 1 is Q4. What about Q4, Q5? Q4, Q5 is already filled. So now this can also be filled. Okay. Now what about Q4 and Q7? Q4 and Q7. Q4 on 0. Q4 on 0 it is Q7 and Q7 on 0 is Q6. What about Q6, Q7? That is not filled. Now we are testing with 1. Q4 on 1 it is Q5 and Q7 on 1 is Q2. Q2, Q5 is final and non-final. That is already filled. So you have to fill this. Okay. Now what about the next one? Q7. What about Q3, Q0 and Q3? What about Q0 and Q3? Q0 and Q3. Q0 on 0 is Q1 and Q3 on 0 is Q2. Q1 and Q2 are distinguishable. So Q1 and Q2. Q1 and Q2 is distinguishable. So this is also distinguishable. Then what about Q0 and Q4? Q0 and Q4. Q0 on 1 is Q5 and Q4 on 1 is Q5. That means same state. What about 0? Q0 on 0 is Q0 and Q4 on 0 is Q7. What about Q1, Q7? Q1, Q7. We are not in a position to fill this. Okay. Now, what about Q0, Q6? What about Q0 and Q6? Q0 and Q6. Q0 on 0 it is Q1 and Q6 on 0 is Q6. And what about Q1, Q6? Q1, Q6 is already distinguishable. So this is distinguishable. What about Q0, Q7? What about Q0, Q7? Q0 on 0, Q1 and Q7 on 0 is Q6. What about Q1, Q6? Q1, Q6 is already distinguishable. So this is distinguishable. What about Q1, Q7? Q1 and Q7. Q1 on 0, Q6. Q7 on 0, Q6. Not distinguishable. Q1 on 1, it is Q2 and Q7 on 1, it is Q2. That means in that case also it is not distinguishable. And what about Q5 and Q6? This point, Q5 and Q6. Q5 and Q6. That is Q5 and Q6. On 0 what will happen? Q5 go to Q2 and Q6 go to Q6 itself. Q2, Q6 is distinguishable. So this is distinguishable. Q5, Q6. What about Q5, Q7? Q5 and Q7. Q5 and Q7. Upon 0, Q5 goes to Q2 and Q7 goes to Q6. Q2, Q6 is already distinguishable. Q2, Q6 is distinguishable. So this is distinguishable. What about this one? Q6 and Q7. Q6, Q7. Q6 and Q7. Upon applying 0, what will happen? 0, Q6 on 0 it is Q6. Q7 on 0 again Q6. They are not distinguishable. And the other input you have to try. That means 1. What about Q6 on 1? Q6 on 1 it is going to Q4. And Q7 on 1 going to Q2. Q2, Q4 is distinguishable. So this is distinguishable. Now, what about Q0 and Q4? Again, we are coming back to 3 entries which are not filled till now. And Q0 and Q4. Q0 and Q4. Upon applying 0, what will happen? Q0 on 0, Q1 and Q4 on 0 is Q7. What about Q1, Q7? Q1, Q7. That entry is not filled. Okay. What about Q1 and Q7? Testing again. Q1 and Q7. Q1 is this and Q7 is this. Q7, Q1 on applying, Q1 and Q7 on applying 0. Q1 on 0 is Q6 and Q7 on 0 Q6. That means both are distinguishable. We are trying the other input. Q1 on 1 it is Q2, Q7 on 1 it is Q2. That means it is not distinguishable. Now, what about Q3 and Q5? Q3 and Q5. This is Q3 and this is Q5. On applying 0, Q3 on 0, Q2, Q5 on 0, Q2. What about applying 1? Q3 on 1 is Q6 and Q5 on 1 is Q6. That means they are not distinguishable. So, here the meaning is, here Q0 and Q4 are not distinguishable. Q1 and Q7 are not distinguishable. And Q3 and Q5 are not distinguishable. So, at this point, we can conclude that we are going to have a conclusion like this Q0 is equivalent to Q4. Q0 is equivalent to Q4. Then Q1 is equivalent to Q7. Q1 equivalent to Q7. And what about this one? That is Q2 is the final state. Q2 is the final state. And now we are having Q3 and Q5 which are equivalent. Q3 and Q5. That is Q3 and Q5. Q3 equivalent to Q5 and Q3 equivalent to Q5, Q4. So Q1, Q2, Q3, Q4, Q5, Q6. Now you have another state Q6 here. Now you are going to rewrite this. That is, here ask this is start state Q0. Starting from Q0, that is the start state. What is Q0 on 0? Q0 on 0 it is Q1. Q1 belongs to this. And what about Q0 on 1? Q0 on 1 end is Q5. Q5 is 1. Now, what about this? What is Q1 on 0? Q1 on 0 is Q6. Q1 on 0 is Q6 and Q1 on 1 it is Q2. That means Q1 on 1 it is Q2. And now what about Q2? Q2 on 0 is Q1. That means Q1. Q2 on 1 is self loop. And what about Q3? Q3 on 0 is Q2. Q3 on 0 is Q2. Q3 on 1 is Q6. Q3 on 1 is Q6. Q3 on 1 is Q6. And what about Q6? Q6 on 0 is this, and Q6 on 1 is coming back to Q4. That means Q4 belongs to this and 1. That means here the final state is Q2. So here also the final state is Q2. That means here we have using this tabular method. That means here this is equivalent, this is equivalent, and this is equivalent. Okay. That means these are the equivalency points. In this way, you can find out equivalent states, and using equivalent states, you can minimize the number of states. Here we have how many states? 8 states, and that is reduced to 5. That means this is the minimum state finite automaton equivalent to this. So with this, today I am concluding the session, and next day we will discuss more on Myhill machines. That means finite automata with output. That we will discuss in the next class. Thank you.